Hey you, it's me. You're closer to being done with this exam than me, so you're doing a whole lot better than I right now. For the basic problem, we were tasked with identifying sampling distributions and using them to prove things. The problem states that the Census Bureau reports that households spend an average of 31% on their spending in housing. But a Cleveland Home Builders Association says that value is less than what the Census Bureau said. We had to identify the sampling distribution with a mean of mu and a standard density curve, and explain which one of the given percentages is closer to the mean. We also had to locate p equals 32.2% on the density curve and all the values below it. When we find the sampling distribution, we have to establish what the mean, the standard deviation, and the standard error are. The mean is 31%, the standard deviation is 9.6%, and the standard error is 0.24%. Each point at the 1, 2, and 3 standard deviation mark is noted on the normal graph shown on the slide. The mean, that is good evidence that the average Cleveland spending is less than the 31% mean, is the 27.6% mean. This is the best piece of evidence because it's the lowest mean under the given 31% mean. We had to find the p-value for the mean of 30.2% mean by finding the z-score of that specific mean. To find the z-score, we had to use the z-score formula. Plugging in our given values for the formula on the screen gives us a z-score of 0.52. When we reference our z-score table, which is pretty fun, this gives us a p-value of 0.6985, or 68.85%. For the advanced problem, we were tasked with finding the margin of error, explaining said margin of error in context, as well as explaining the correlation between the margin of error and the ever-ominous confidence interval. The problem states that Pew Research, which is pretty cool when you look at real-world stats, polled a random sample of 799 teens about their internet use. 49% of these teens reported manipulating their age on the internet to access sites that they could not otherwise access because of their age. We had to find the margin of error for a 95% confidence interval and explain it in context, as well as define if having less confidence in our interval, for example, the 90% used in this problem, results in having a larger or smaller margin of error. To find the margin of error with a confidence interval, the steps you take are easy. Just establish what level of confidence you want to have, which in this case is 95% confident, and establish what kind of test you need to use, which is a 1 proportion z-test. So here, we're going to use a 1.96 z-score, which is a 95% confidence interval. And the formula, square root of p times 1 minus p over n. In this case, p equals 0.49 and n equals 799. Plugging in these values along with the given percentage of 49, we're given the confidence interval on the slide. But we aren't looking for the confidence interval, we're looking for the margin of error, which is 0.0347. In context, this means that from the 49% of teens that confess to lying about their age, there's a 95% chance that there are between 3% more or 3% less teens that have manipulated their age online so they could get games like The Elder Scrolls V Skyrim. I would do that, but I'm already 17, so I'm fine. If the confidence interval were changed to a 90% one, instead of a 95%, the margin of error would be a lot smaller. Well, at least a little bit smaller. This is because the z-score used with the 90% confidence interval is smaller than the z-score used in the 95% confidence interval. You can prove this by calculating both of those margins of error and comparing the two. As you can see, the margin of error for the 90% confidence interval is smaller than the margin of error for the 95% confidence interval. Boy, do I love the phrases confidence interval and margin of error. We're done with them? Oh, good. The AP problem, we're tasked with finding confidence intervals. Are you kidding me? We also had to explain why assuming things is wrong. This problem states that a random sample of 1,026 adults were taken from the United States population, and these men and women were asked a question regarding the Social Security system of the United States and what they would like the President and Congress to do regarding that system. All responses were recorded in percentages, so there are not exact numbers unless you really want to work all those numbers out, and I don't really want to do that. We had to find the 95% confidence interval for the people that would respond, make some major changes to the system, as well as interpret this interval as we found it. We also had to explain why assuming the study indicating that we should not make any changes to the system is misleading in all ways with regards to the given statement by the bias guy. To find a confidence interval, we have to put our pants on. You got him? Good. First off, our parameter of interest, which we will call P. P represents the proportion of all U.S. adults that would make major changes to the Social Security system. Secondly, we must make our assumptions on randomness, and if the sample is big enough and small enough. The problem already states that the adults were randomly selected from the population, so we don't have to worry about that part. We must assume that there are more than 10 times 1,026 adults, which is 10,260, in the United States. We also must assume that the distribution is approximately normal because both the formula n times p and the formula n times q are greater than 10 in this situation. Thirdly, we have to name our test, which I already said that it's a 1 proportion z interval. To finish out this part of the problem, we have to test our values. To test this confidence interval, we have to plug in all the necessary values into that whole confidence interval equation that I don't want to say. It gives us a confidence interval as it's displayed on the screen. I don't want to say that either. It's cool. Yeah. This means we are 95% confident that the mean of the people that would say make some major changes is between 36.02% and 41.98%. Alright. Assuming things. That's bad. Don't assume things. Especially somebody's gender. The advocate in this problem makes his claim in this problem to be stated against changing the system. He's already stated to be biased, so it makes me cautious, and it makes me kind of upset because they use bad data. But, well, he used biased reasoning, but whatever. When we look at the statement, the advocate mentions that the percentage of people who want no changes or minor changes is 41%. There's people in that percentage that want changes, being them only minor ones. It's 100% misleading to assume the plurality of people want changes. Just because they don't want many changes doesn't mean they don't want them at all. And I won't even mention the people that weren't accounted for that want a complete overhaul of the system, because that's still a significant amount of people. Yeah, that's really it. I'm sorry this is late again, Shaheen, but I hope you're doing okay, Mads.